All right, I know that breathing exercise is a little silly at times, but you guys did a fabulous job. I think I only had like one person at the beginning flipping through her folder and another person entirely all the way through, just like writing with their pencil. One comment, but other than that, oh, you guys were awesome. So the great thing about having this new curriculum is that we have it all at our fingertips. If you ever get behind, it's all here. Okay, so I really want to emphasize that fact, and I will continue to emphasize that fact because I know the more we hear it, the more I know. So I'm on page 9 in my packet, and I'm gonna skip through the lesson materials that we've gotten through. So we have gotten through all of the examples, and we are now doing some of the apply before we practice some more on ourselves. So what I love about the examples is they have those little check sections. So even after this apply here, we're also going to be checking our work there. So we are definitely quite a ways through here. There's example 4, extra examples. So both the check and the extra examples, using those as a way to make sure we are understanding, have been very beneficial, and we can go back and look at those too when we're getting to our practice section here in just a bit. Okay, everybody see this on page 9? Awesome. Mammals. The table shows the average weights of 2 endangered mammals. How much more does the brown bear weigh than the panther? So first of all, we're trying to decide what is the task, and they have some ways to help you understand, right? Make sure you understand exactly what the question to answer or problem to solve. I don't think that's proper English, but okay. You may want to read the problem 3 times and discuss these questions with a partner. So the context of a problem, we have 2 animals' weights. That's pretty much the context. So let's read it again. The table shows average weights of 2 endangered mammals. How much more does the brown bear weigh than the panther? Okay, now I'm looking at the table. I see the panther's weight has an exponent and some multiplication. The brown bear's weight also, has some multiplication and an exponent. So second time, what mathematics do you see in the problem? What do we have to do? We first have to multiply and write out our factors for our exponents, and then so we're having to figure out how much more. How much more means we're doing what operation? Excellent, excellent. We're finding the difference, so we're subtracting. And finally, third time, any wondering? So the table shows the average weights of 2 endangered mammals. How much more does the brown bear weigh than the panther? When we're looking at their weights, I'm wondering if there's any way we can simplify so we're like taking out a factor, right? We have 3 2s here. We have 2 5s and 1 5 here, but 2 3s and 1 2. Oh my gosh, I keep saying 2 3s. 3 2s and 1 2 here. So I'm wondering how we can get through that. All right, so how are we going to approach it? What should we do first? What are we going to do, Xander? Math. I think that's a great strategy to use. We are going to use some math. Maybe this Xander can elaborate on what kind of math. Subtraction. So we got to do subtraction, but before we can subtract, what do we really have to do? We have to solve those powers. Good, with our exponents. Okay, so I'm just going to write here, evaluate powers, multiply, then subtract. What are we subtracting? It says we want to know how much more the brown bear weighs than the panther. So we're going to say brown bear minus panther. Does that work? Oh, you got it already. Good. Bear minus panther. All right. So use your strategy to find this problem. So we have to come up with the solution. The something weighs how many more pounds? All right, so let's look at our weight. Remember, let's write out our powers. I gotta do it on the annotation. I just remembered that we're recording this for all time's sake. All right, so let's annotate. Maybe here we go. All right, so remember, I have 2 as a factor 3 times. So 2 and 2 and 2. And remember, I'm multiplying. I know my handwriting's not pretty with this pencil. Times 3. Oh, hello, kitty. Times 5. I guess it's not a cat, it's a panther, but it looks what is it? Okay, so I love to use carrots if you need to remember which ones you have done. So 2 times 2 is 4. 4 times 2 is 8. 8 times that 3 is 24. And 24 times that 5.
120.
Good. So half of 24 is 12. And then if I multiply it by 10, that's how I figure out my 5s, because 5 is half of 10.
I just have to even number them.
Perfect. And if it's an odd number, it's going to end in 5. All right. So here I have 1, 2, and 2 5s.
Not very nice.
Man, that poor 5 is gonna go home tonight and say, oh. All right. So 2 times 5 is 10. Times 5 is 50. Times 7 is 350, right? So 350. Now, we said we were going to say the brown bear minus the panther. All right, I have 0 minus 0 for my 1s. I have 5 minus 2 for my 10s and 3 minus 1. Good. So 230 pounds. Now, you could have gone about this a little bit differently, right? What if I canceled out a 5 here, because this has a 5 here, and canceled out a 2 here and a 2 here? Then I could have said 4 times 3 is 12. And 5 times 7 is 35. Does that get us where we needed to go? Not really. I'm just showing you other ways people might look at it. It's okay, and probably better that we didn't look at it like that. Okay, I was just wanting to see how that pattern might come into play later. All right, what is your solution? The brown bear weighs how many more pounds? 230 more pounds than the panther. All right, so somewhere under 3, hopefully you can write your solution there. The brown bear weighs 230 pounds more than the panther. I'm not going to check that answer, because when I do, it like gives the answer to the next hours, and I have, even when I click reset, it's obnoxious. All right, how can you show your solution is reasonable? I don't know. Show your work. Think about how big a brown bear is. That big bear and that little cat. I would say probably me a cat, since it looks almost as tall as the bear. All right, so if a female gorilla, we have this little talk about it on the right side of that column on page 9. It says a female gorilla weighs 2 to the 3rd, or 2 cubed times 5 squared pounds. How does this compare to the panthers and brown bears' average weight? So we have to figure that out. What's 2 cubed? 8, right, times 5 squared, 25, so that's like 200 pounds. How does it compare? Where does it fall into those things? Right, yeah, right in the middle. He's kind of between, a female gorilla is between the size of a panther and a bear, right? Oh, really? They're bigger. All right, here is your check. So on page 10, at the top of page 10, Interstate 90. Remember, guys, we're gonna follow their pattern and their process because it's nice and slow and deliberate, and I feel like it's something that we can use as good strategies when we're test taking or even doing math in class. So Interstate 90 stretches almost 2 to the 4th times 7 squared times 4 miles across the United States. Interstate 70 stretches almost 2 cubed times 5 squared times 11 miles across the United States. How much longer is Interstate 90 than Interstate 70? All right, so our context is that we have 2 interstates. We're trying to figure out which one is longer, and we've got some math in here. So let's read it again to look for the math this time. Interstate 90 stretches almost 2 to the 4th times 7 squared times 4 miles across the United States. Interstate 70 stretches almost 2 cubed times 5 squared times 11 miles across the United States. How much longer is Interstate 90 than Interstate 70? So what math are we doing? We have what? Got powers that we have to evaluate. We have multiplication we have to evaluate. And then to find out which one is more, we have to find the difference, which means we're going to have to subtract. So go ahead and try those. Evaluate how long Interstate 90 is. Evaluate how long Interstate 70 is. Start writing it out. You should be working. All right, let's work on multiplying. Multiply, multiply, multiply. Some of these you'll get good at seeing, like you should know by now that 2 cubed is 8. So some of those we should get good just so like knowing. So here was 2 cubed, we should know this was 8. 8 times 25 times 11. We know this is 3 were 8, 4 must be 16. 7 times 7 is 49. Remember, multiplication is commutative. We can do it in any order. So I could say 16 times 4, since that's something I know, and that would give us 64 times 49. Gosh, I write so slow like this. I'm sorry. Oh, that's awful. There's got to be a better way. Okay, so I would write these out. 64 times 49. This is a great review, right? 9 times 4, 36, so I'm carrying the 3. 9 times 6, 54 plus that 3 is 57. Don't forget to cross out that 3 now that we've already added it and hold this place. 4 times 4 is 16. So I'm putting the 6 here and carrying the 1. 4 times 6 is 24, plus that 1 makes 25. I've got everything lined up. So now I can simply add 6, 13, carry the 1, 11, carry the 1, 3. That's a pretty big number. That's how many miles Interstate 90 is. 3136. I'm gonna start that subtraction problem up here. 3136. And I'm subtracting whatever Interstate 70 is. So 8 times 25, I'm thinking quarters, so I know right away it's 200. 200 times 11. Well, 2 times 11 is what? What's 2 times 11? 22. And I have 2 zeros. So 2200. So that one was not nearly as difficult. Right? I've got 2 zeros because I wasn't multiplying by 2, I was multiplying by 200. So I'm going to write that here and be sure we can subtract those to find the difference. Hopefully you are doing this or have done it already. 6 minus nothing. 3 minus nothing. Can I take 2 from 1? Nope, gotta borrow. So this becomes a 2, this becomes an 11. 11 minus 2 is 9. So how much longer is Interstate 90 than Interstate 70? 936 miles. Do you see how we got there? Anybody not see how we got there? I feel like this was kind of order of operations to solve it, right? We had to do the exponents first before we, and the multiplication before we did the subtraction. So that's why it's a little bit like what we're doing and how we apply. All right, so I just want you to pause and reflect really quickly. How well do you understand the concepts from the last 3 days? How well do you understand these concepts? So as you're going back and looking at them, how well do you understand them? What questions do you still have? And how can you get those questions answered? So jot a couple things down. How well are you understanding? It's a good thing to be able to reflect and know where you are in this process. All right. It's always super important with these extra apply problems. There's lots of space still on page 10. It's extra, which means it's not in your packet, but it does tell you right below the check, go online. You can complete an extra example online, right? So the table shows the minimum areas of different sports fields. How much greater is the area of the field hockey field than the area of the men's lacrosse field? Field hockey field. So let's look at the table. We have field hockey, men's lacrosse, and women's soccer. Well, this is interesting. So the table shows the minimum areas of different sports fields. How much greater is the area of the field hockey field than the area of the men's lacrosse field? So which area do we not even need at all? The women's soccer, exactly. So that is just extraneous information. So do you see how we have to figure out the men's lacrosse and the field hockey and then see which one's more? They're telling us which one's more already. How much greater is the field hockey? So we know we're going to do field hockey minus the lacrosse. So go ahead and try that on your own. I want you to practice before I catch up here in just a moment. If you're struggling with this 10 to the third power, remember this has 3 zeros in it. So essentially 2 to the 6 times 1,000. And this becomes 9 times 7, so 63 times 1,000. So 63,000. So that one was easy. Be sure you know how I got there though. Hey, where did my 63, and there's 3 zeros because that 10 to the third has 3 zeros. Oh my, okay. 2 to the 6th power. Well, 2 times 2 times 2 is 8, and 2 times 2 times 2 is 8. So 8 times 8 is 64. So 64,000 here. So right away, without even having to line those up, how much greater is it? 1,000. 1,000 square feet. See how they write feet squared? We would read it as square feet. Cool? All right, so we are going to, so that, oh, please let me, there we go. Maybe. Hello. Oh, that's it. That's the end of the resources. Okay, so I'm going to switch over and stop sharing that screen so you can kind of look at what this practice looks like. This practice is literally what you are doing on your own to practice. Okay, so if you're having a hard time, guys, turn it off for just one more second. If you're having a hard time, remember to go back. Each section has their own examples. So this first section would be like example 1, right? And example 2 would be number 2. Do you see that? And it even tells you right here, examples 1 and 2. So you can go back in your workbook to see where it's at. Evaluate each numerical expression, example 3. So go back to example 3. I love this. This is so beautiful. Example 4, example 5, and then this stuff back here. You've got some applied down here. You've got some trying to do some test practice. In here, you're really just saying which one's bigger. So you're just evaluating like you were up there. Okay. So that is it. You have some more apply on the back. You have the entirety of the hour for pages 11 and 12. So you still have over 20 minutes. Get started. Remember, the first thing you can always do is write things down. Start writing down the numbers. Don't just sit there and go back and look at your examples. Use that resource. If you do get done, you may log into Alex. I know we haven't given dedicated class time to that this week, so you won't have to worry about those 3 lessons being completed in Alex this week. Hopefully, as we get into this curriculum, it will be easier to give some more dedicated class time to that. It's super important. All right, I think it'll be super helpful. Remember, the expectation is your noise level. I was gonna say your news level. Your noise level is between a 0 and a 1. So you may whisper at your tables, help each other out when needed, but please keep it math related so that when I have to help people, it's easier. All right, cool. All right, keep working hard and try these out.